Hi guys, this is Ms. Martinez, and in this video we are looking at quadratic functions in standard form. A few of your objectives are to be able to graph quadratic functions in this form by transforming the parent function. And that parent function again was the most basic. It was just f of x equals x squared. So we're gonna transform that function. We're also going to need to be able to continue to determine your vertex, domain, range, and axis of symmetry when you're working in standard form. Standard form of a quadratic function looks like this: ax squared plus bx plus c. That's the form that you're most probably familiar with seeing them in. A, B, and C are real numbers, and A still cannot equal 0. And we saw previously in our last lesson why that was true. So a few properties, because now that we're working with a different form, we're going to look for things a little differently. Your vertex isn't so clearly visible. You're going to have to do a little bit of algebra to find it. The x value of your vertex will be the opposite of b over 2 times a, and that matches your axis of symmetry. Just like in vertex form, it was the x value of your vertex that gave you your axis of symmetry. And then we just substitute that value into the function to find the y value, the output. Now, the rest of this is much like you've already seen. If a is greater than 0, meaning it's positive, it's happy, it's going to open up. And if a is less than 0, it's negative, it's sad, it's a sad parabola, and it's opening down. If a, the absolute value of a, is greater than 1, it's going to be narrower than your parent function. And conversely, if it is the absolute value of a is less than 1, it's going to be wider than your parent function. So let's work through some examples here. The first step when working with graphing in standard form is to find your axis of symmetry. So we'll take the opposite of b, which is negative 8, over 2 times a is 2. And let's simplify this. That would be 8 over 4, which is 2. And here's my line right here, going through 2 on my x-axis. All right, and now the vertex, we know it's going to be our function at 2, so we'll substitute in 2 into our equation and simplify. That'll be 2 times 4 minus 16 plus 6. So that is going to give us, when you multiply that product, that'll be 8 minus 16 plus 6. All right, so that's going to be negative 2. And we can plot that point. And good deal, it is on our axis of symmetry. That is where our vertex should be. All right, so let's keep going here. Let's find some other points. You could use your table on your graphing calculator, or you can use the 135 shortcut. Either approach will work. If you're going to use the 135, pause the video because I used just a table here. And you can check yours in just a moment. At 1, because that's a nice small number close to my axis of symmetry, the output is 0. So we'll plot that point and we'll reflect it. Now on that same side, let's go 1 over. At 0, if I plug that into my function, the output would be 6. And we'll reflect that. And that looks like about all we can fit. So now you would want to take and you would want to connect these in a nice parabolic shape, which I can't do on mine, but do make sure that you go ahead and actually sketch the parabola using these points. All right, now let's do another. First step, axis of symmetry, opposite of b over 2 times a, and we'll simplify. That's negative 4 over 2, which gives us negative 2. Sketch our axis of symmetry, going right here through negative 2 on our x-axis, nice vertical line. And now we'll plug negative 2 into our g function to find the output. Alright, so we substitute that in. We'll begin to simplify, so that will be 4 minus 8 minus 3. And that gives us negative 7. We'll go ahead and plot that point, and it barely fits down there right here at negative 7, and it is on our axis of symmetry, so we're doing good. Now you can do the 1, 3, 5 trick, and I'll also populate the table so you can see that. So if you were to go over here, 1, and plug in your a value, it would just be up 1, which this point is negative 1, negative 6. Right there. And reflect it. And then if you go over another, it would be up 3 times your a value, so that would be 1, 2, 3. Well, that point is 0, negative 3. We can plot that and reflect it on the other side. And it looks like we can do a little bit more. We can go over 1 and then up 5. 1, 2, 3, 4, 5. So that's going to be 1, 2. Plot that point and reflect it on the other side. And now we have a nice parabolic shape. And you could take your pencil and connect those real nicely so that you have a nice parabola. All right. On this one, I want you to pause the video and try to do it all by yourself. So go ahead and pause the video and then stay tuned. I'll show you the results in just a moment. All right, your axis of symmetry should have been at x equals negative 2. Your vertex would have been at negative 2, negative 5. If you missed that, look for your error in your algebra. And then some points that you would have had would have been negative 1, negative 4.5. You would have only gone up half there. 0, 3, you would have gone up 3 times just a half, so that would be up 1.5. We can do a couple more here. At 1, it would be negative 0.5, and you can reflect that on the other side. And then you would just want to sketch this, connect those dots in a nice parabolic shape. All right, now some slightly different style problems here. Now we're going to use our understanding of the graphs to answer some questions. Is this quadratic going to have a minimum or a maximum value, and what will that value be? Well, let's think back to our properties. Your properties said, and let me see if I can go there real quick. Oops. Nope. Sorry, guys. Here we are. Okay. Back here in the properties, there it is, we said that you're going to have a parabola opening up if it is a value greater than 0, and a parabola opening down if your a value is less than 0. So on this application problem, we have a positive a value, which implies that it's opening up. If it's opening up, if you maybe imagine your happy parabola with your arms, you're going to have a low point, a minimum value. And where does that happen? It happens at your vertex. So we need to find the x and the y value of our vertex. And we substitute in there. It would be the opposite of 6 over 2 times 3 halves, which is negative 6 over 3, which gives you negative 2. Now that isn't the value, that is where it happens. Let's find what is that maximum value by plugging it into our function. And simplifying some here, we're going to take negative 2 squared, that's going to be 4. And the 6 times the 2, that's going to be negative 12. 3 halves times 4, that's really going to be like, you can simplify, and it'll really be just 3 times 2, so that gives you 6, minus 12 plus 4, and then we'll simplify that, and it gives us negative 2. So at negative 2, the minimum value there is negative 2. All right. Something else I want you to be able to do is to, given vertex form, write it in standard form. So how would we go about doing that? Well, standard form requires that you have each term kind of like by itself, the squared term, the linear, and the constant. So we're going to go ahead and we're going to rewrite this, because x plus 2 squared is the same thing as x plus 2 times x plus 2. And you could sing the song, but if you forgot the song, then you could just do each of the algebraic steps here. So the first would be x squared, and then you would FOIL that on out, so you'd have 2x plus 2x plus 4, and then that minus 4 is out there on the end. Combining like terms, the 2x and the 2x together, that gives you 4x. And as you can see here now, the positive 4 and the negative 4 are going to cancel. So in standard form, it would look like x squared plus 4x. All right, so that is rewriting it in standard form. Let's do another one. This one's a little bit more challenging because, as you can see right here, our a value, we have something other than 1, so we're going to have to be careful. Let's go ahead and sing the song to expand what is inside the parentheses. Take the first term, square it, take the second term, square it, take the first times the second, which would be negative x, times 2, that's negative 2x. Now this negative 3 is still out in the front, so we're going to distribute that into every term inside of your parentheses, which will give you negative 3x minus 3. Now this is going to be positive 6x, and then this was outside the parentheses, so it's just kind of hanging out there. And let's combine terms and put it in standard form. The negative 3 and the negative 4 give you a negative 7, and now our 6x is going to be in the middle, because you want to go from the highest, which is 2, a power of 2, to no powers over here. All right, here we go. We've about reached the end. I want you to try this one all on your own. Pause the video right now and graph this quadratic in standard form. All right. You would first need to find your axis of symmetry, which is going to be at negative 2. You'd want to sketch that, as you can see right here. And then you'd want to find your vertex by substituting in negative 2 into your function. And if done correctly, check all your algebra here, it will be at 10. So you may have had to extend your graph a little bit to make that fit. All right, now you would use your table or your 1-3-5 trick, over 1, down 2, and reflect that onto the other side, and then over 1, down 2 times 3, which is going to be 6. 1, 2, 3, 4, 5, 6. and I think we can go a little bit more, over 1, and I'm going down because this is negative, and we're going to multiply this times now 5, so that's going to be down 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. All right, there's our beautiful graph. You would just want to connect the dots and make a nice parabolic curve. Last one here for you to try on your own. Pause the video. Is it a max or a min? And what is that value? All right, let's see what we have here. Our A value is less than 0, which implies that the parabola opens down. And if it's opening down, it's going to have a maximum value. And that's going to happen at our vertex. So we plug in our B and our A value into the formula to find the vertex. And we take that and plug it into our function to find the output. Our function at negative 14 is 51, which means we're going to have a maximum value of 51 for this quadratic. Ladies and gentlemen, that is it. If you had questions, make sure you write those down and we will answer them together. See you soon. Thanks.